All right, this is it, the home stretch. After sitting through that last video with lots and lots of words, I wanted to make this one have useful animations, actually demonstrating a trick that you can do with a pen and a pad or an iPad or anything just sitting right in front of you to better schedule your stuff. The things on the right are instructions that you want to schedule. It's your program, basically. We have 5 odd instructions. We have 8 even instructions. The max of those two is 8. So if you remember from the previous video, I'm going to guess that my initiation interval should be 8 slots. And I'm going to go ahead and try and find a schedule that fits in here. So let's get started. How do we do this? First instruction of your program is an odd one. So it goes into the odd column. And you can just go ahead and put it in the first slot. No problem. Now we have our first even instruction. Even and odd, they don't depend on each other here. We can just go ahead and dual issue that in the first slot. Now mind you, if it were to really dual issue, the even would have to come before the odd, but I didn't really think this example through. I just kind of threw some boxes on the screen and said I hope it works out, so bear with me and don't totally freak out over the details. So, another odd instruction to schedule seems like it does not have any dependencies, so we can go ahead and put it in the next available odd slot. Okay, our first dependency of the example. So this even instruction seems to depend on the odd instruction. The odd instruction takes 6 cycles to finish, so we cannot issue this even until 6 cycles after the odd is issued. So it has to go way down here. All right. Now we have an odd with a dependency on the even. The even takes 2 cycles, so we cannot schedule the odd until 2 cycles after. Luckily for us, that's the first available odd slot anyway, so it just kind of works out. Okay, now we have an even depending on this even. 2 cycles later, because the even takes 2, it goes over there. Okay, now here's where we get really interesting, and this will hopefully demonstrate the modulo concept to you. So we have an even that takes 6 cycles, and we want to schedule something that depends on it. That means that we can't schedule it until 6 cycles later. 6 cycles later happens to be down here off the edge of the window that we committed to scheduling in. What you do in this case is you wrap around to the beginning and you find the first available slot that you can put this in. So 0, we would like to put it in 0, but 0 is taken, so we're going to go ahead and put it in 1. Okay, now another thing with no dependencies, we can just go ahead and schedule that there. Another dependency has to go 2 cycles after the thing it depends on, so it goes down there. An odd that depends on this even goes 2 cycles after the even, so we should put it in 5, because 3 plus 2 is 5. Excellent. This is actually working out kind of well. So now we have another wrapping around case. So this even instruction depends on this odd. The odd takes 4 cycles to finish, has a latency of 4. So we're going to wrap around, and we're going to find the first even slot that we can put it in. Cool. We're almost done. So, oh, another odd with no dependencies, and I believe that this even has no dependencies either. Okay, cool. So now, regarding the color, the important part here is that everything from particular iterations are colored the same. So you're going to go through this loop and you're going to look at it in assembly and you're going to see all these instructions, but it's going to be very, very hard for you to know that, oh, well, you know, this even is not going to be used until the iteration after, and this even is going to be used the iteration before. And it's the colors is basically what I use to keep track of what belongs where, so I can better visualize things. Hopefully, despite all the glaring factual errors that that were in this example, hopefully that gives you an example of how the scheduling works, and we can move on finally to some final tips. Finally. Okay, so like I said, be super careful when keeping track of your registers, like on the reels, yo. Or make a tool to do it for you, if such a thing could ever possibly exist. Because like I said, you're going to have multiple iterations in flight at once, and it's going to be crazy hard to figure out, you know, what belongs to what. So I use colors. Some other people, you know, use numbers to say, oh, this is 0, this is 1, this is 2, whatever iteration or generation it belongs to. Point number 2 It is generally a bad idea for a register to live longer than one loop iteration. That's calculating something into a register at the very, very bottom, and then, when you wrap around, not having it be where it should be based on where other things of the same type are starting. So you may want to use copies at the very end to copy things into the expected registers, which is called splitting lifetimes, unless you're trying to be really clever and you think you know what you're doing, which you very well may. Induction variable reversal. I'm not going to talk too much about this transform, but it's fairly cool. Think back to the original video where we had pointer updates and things, and we're reading from the pointer and then doing the pointer updates. If multiple things in that loop were using the pointer, we would not be free to update the pointer, to increment it until everything that was using it is done using it. So what you really want to do is you want to decouple your pointer update from the things that are using it, and then have the things that are using it. You could even update it in the beginning of the loop, and then have things that are using it, just subtract a small offset from the pointer to get what its original value would have been anyway. That's one way to do it. Extremely important point. The more balanced your odd-even split, the smaller your initiation interval. If you have 50 odd instructions and 3 even instructions, your initiation interval is going to be 50. And there's really nothing you can do about that. If you balance it out a little bit better and find some substitutions and get maybe the even pipeline longer and the odd shorter, your initiation interval is only going to be as small as your worst case for each pipeline. So go ahead and balance. Look back to the post I did before this for some ideas there. And finally, because I didn't really go into details, please go look up IMS and SMS and all this other stuff on the internet. There's some incredibly interesting papers. Ask me if you want. I probably should have included the reference slide in this video, but I'll probably just post it on AltDevBlog. So yes, go ahead, check it. I mean, maybe I'm remembering information wrong. I haven't done this stuff in a long time. Who knows? I'm tired. I have to record a video that's 25 minutes. I forget to say things. It's better off that you probably just go out and look at all this stuff yourself. End of video. Thank you. Hopefully you enjoyed it. Next time I do a video post, it's going to be way shorter. It's going to be just small, tiny little stupid SPU tricks that I can talk about in a minute and a half and demonstrate with some cool animations. Thank you for putting up with me. Hopefully you learned something, and I will see you guys in the comments section. Later.